All right, we'll get the business end out of the way. Well, welcome everybody, and thank you for taking the time out to attend tonight. As you can see, we're having a little bit of a technical difficulty here, but we will have our presentation. Our speaker is making alternate plans to access the internet in a way that she can make her presentation. So we're going to get the business end of things out of the way. For anybody that doesn't know me, I'm Chris Wenzel, the current president of the LIAPG, and welcome everyone so much. A lot of you have seen this before, but we always want to thank our corporate sponsors. We have 7 of them. PW Grosser at the diamond level, and at the topaz level, we have Alpha Environmental, Castleton Environmental, EnviroTrack, ERM, H2M, and Island Pump and Tank. If you're not familiar with these organizations, you can go to our website. There is a scroll there with their logos, and if you click on the logo, it will take you to that particular company's website, and you can learn more about them. But we appreciate the support both from our corporate sponsors and our individual members. You guys make it all happen, and we wouldn't be there without you. A little bit about upcoming events. These Zoom meetings have continued on pretty much on a monthly basis. They're usually the 3rd Thursday of every month. And after tonight, hey guys, we don't have any speakers. So we're looking for speakers. And, as Jennifer mentioned earlier, if you have something, please come out and support us and make a presentation. Well, I'm sure lots of people have canned presentations they've already done, and the effort is pretty minimal. We would appreciate very much. It's an effort. It's an effort to find people, and we're constantly doing it. As far as field trips go, we don't have any scheduled. We had the field trip to the Museum of Natural History in New York City, the American Museum of Natural History, to the Hall of Gems and Minerals. It was a guided tour this past summer. It was really great. If you haven't been there and you couldn't make the trip, you should go check the place out. I would recommend you go early. Doors open at 10 a.m. and that's when it's least crowded. So, browsing the cases and looking at all the specimens is really cool. They've done a really nice job redoing it. But we are working on some ideas. But if there's anybody that has an interesting field trip that they'd like to bring up to our attention, please get in contact. You can email us through the website, lipgprez@gmail.com. So stay tuned. We're still trying to have something before the winter sets in. Our board meetings are held monthly on the first Monday of every month generally. They're online, and we're moving back to having some face-to-face meetings. But either way, if anybody's interested, we are, as we show in our statement every time and on our website, we're an open organization to everybody. If you're interested in getting involved or just finding out what we do, get in touch with us. We'll set you up with a link or let you know where we're going to be meeting face-to-face in person. So always looking for help. A little bit about upcoming events from our brother and sister organizations, and you can see here there's 4 other organizations in New York State. There's the New York State Council. They're going to be having in October. If you haven't, you probably all should have seen the announcements. 2-day event, Geology Days. There will be in the next day or two a new agenda coming out of speakers and topics. So watch for that. There's still time to sign up. It's going to be a pretty exciting event. It's upstate, Saratoga Springs. Buffalo, BAPG, check their website, occasionally you go on there and there's not much to see, but these other organizations, when they have something that they're planned, they post it and they send out announcements. HUMCA, which is the Hudson Valley, Mohawk Valley. Next week, they've got a presentation. It's in person only, but it looks to be a good one from a professor at Plattsburgh, I believe. You can see there lithostratigraphic, biostratigraphic, and morphostratigraphic evidence for lake glacial events. Talking about a catastrophic breakout of a lake failing. That should be neat. Again, Northeast American Institute of Professional Geologists. Again, there's a lot of organizations here that have a lot to offer. So check them out. We try to all support one another, and so we're doing so here. In Pennsylvania, you've got the Pennsylvania Council of Professional Geologists. They've got, how timely, on Halloween, a webinar, forensic geophysical methods used to assist law enforcement agencies with locating clandestine graves. Might be interesting if you're into geophysics. More locally, Geology Open Nights at Stony Brook University. They do them both in person and as well as virtual online. You can go to the Stony Brook website, just Google Geology Open Night lectures, and you'll find it. The next one's on the 23rd of September. And thematically, it's close to what we're doing tonight, talking about soils on Mars. Why is Mars red? So I encourage you to, check it out, support it. Attendance is what makes these things keep going, keeps people interested in perpetuating these different events. The ASBOG exam schedule is posted here. The next one's in March. Your application deadline is at the end of the year. If you're interested in taking that exam, either the first or second exams, don't delay in getting your application together. It takes time to do a good one. So, and then the second one's next October. They're given twice a year, March and October, and you can see the deadlines are, basically 90 days in advance, more or less. You can also check out our website, employment opportunities. We post them on there when they're brought to us, and we encourage everybody on this call, if your company is hiring, or a governmental agency, they're hiring, please reach out to us and send us the information. We'll post it and get it up there. And we do have a lot of people visit the website, so check it out. That's pretty much the business end of things. I don't know, is Caitlin back yet or no?
Hello, I'm here.
She is. And how are we making out now?
I had to send Jennifer my PowerPoint.
Okay.
So I think I'll, once everybody's ready, I'll start sharing my screen, and hopefully no inappropriate text messages come in while I'm sharing my screen, because my text messages come up on my computer screen.
Okay, so I'm gonna leave the recording going, and I'm gonna stop sharing, and we'll splice it later. Is that good?
Yep.
Okay. Cool. You got the con.
Chris, PDH instructions.
Yes, right. Oh, yeah. Okay. So for those of you who are seeking PDH credit for for attending tonight's presentation, you need to be here now, and you need to be here at the end. We have a code. I see people are already throwing it in the chat box, LIAPG-214. Please put that in there as a record of your attendance now. And we'll ask at the end, we'll have 3 simple questions regarding the lecture. And that basically documents your attendance, that we can then issue the certificates and provide that information to the New York State Council, who is charged by the state with keeping the records. So we'll get to that. And then your certificate, you'll get it in a week or 2. Sorry, it's a little slow time. Sometimes this is a part-time job, and it takes a little while to get these things done, but we will not forget about you. And if you are, if you think we did, send an email, we'll respond. So there you go.
Okay, while I am presenting on this screen, I'm going to have to keep myself on mute, and I will not be able to mute any speakers that are not supposed to be speaking. So Chris, you might have to do that. I'm trying to log on to my second computer to be able to do that. Caitlin, how do you feel about questions during the presentation? Do you want them to be held off until the end?
Sure, because I don't think I'm going to be able to see the chat box during.
Okay, so I think if anybody has questions, they can go ahead and put them in the chat, and we'll address them at the end.
And I'll just make the formal introduction. Thank you, Caitlin. Dr. Ahrens from NASA Goddard Space Center for coming back a second time to provide us an entertaining and informational presentation on Mars, past, present, and future. And I know Caitlin will emphasize the geologic aspects of it, as well as all the other good stuff that we've learned. So thank you again. We really appreciate it. And with that, I'm going to be quiet and let you go.
All right, thank you all so much for having me back. It's been it's been an interesting evening with technical difficulties, but thank you all so much for hanging in there with me. I'm so excited to chat about Mars geology, especially everybody in this virtual room here is avid geologists here. So there's a lot to be said with Martian geology, though. What's fascinating is that we use Earth as a fantastic analog, and I'll be showing some slides on that here in a bit. So Earth is a fantastic playground, if you will, for not just studying our own planet, but to study other planets as far as different rocks and minerals go, to also different kinds of geologic processes, understanding the different kinds of volcanoes and glacial systems and even faults on Mars. We can certainly go to other places on Earth and study those as well. It's certainly a lot easier to travel around Earth and not go all the way to the dusty red planet. So next slide, please. So just a little bit about Mars. Next slide, please. It definitely has some interesting temperature differences. So it could get down to negative 230 degrees Fahrenheit, up to a balmy 70 degrees Fahrenheit. No magnetic field, a very, very tenuous thin atmosphere. One day on Mars is about just a little over 24 hours, and what we consider to be a terrestrial rocky planet. Next slide, please. So early geologic maps on Mars are very, very fascinating, and I highly encourage everybody to Google such maps. Most very fascinating maps of Mars were from Percival Lowell. So interestingly enough, though, what you're seeing here, though, is upside down, though, because looking through a telescope, the image is inverse there. But notice, though, all these little crosshatch markings here, and for a long while we thought these were canals or canali. And with that said, could there have been ancient waterway systems and aqueducts and whatnot all over the surface of Mars? Really, really interesting part here, though, and you can use this as a sort of fun experiment on yourself. Is you just kind of stare into a light for a little too long, you start to get some squiggly lines in your vision. That's essentially what's going on here. Is that you stare into a telescope for too long, especially in a somewhat dim object for long enough, you're going to start to get a little bit squiggly vision there. So next slide, please. So obviously, all of those beautiful straight-lined canals are not really. They're just more of an optical illusion, if anything. But it did give us a grand sense of exploration. It gave us a nice push toward wanting to understand the geology of Mars a lot better. So this is our most updated geologic map of Mars. Every single color that you see here on this map is a different geology. So beautiful, beautiful colors here, but notice just how complex and varied the geology is on Mars. So all of these different colors. So a lot of the pinks and reds that you see on this map are mostly volcanic areas. Some of the more brown areas are lava plains. A lot of your green and blues there are very icy, low plains, low-lying plains there and whatnot. So all sorts of fun geology there. Next slide, please. All right, so how many missions have there been about with Mars? So quite a few. Next slide, please. So only a few flybys, but it's mostly been orbiters and certainly a plethora of landers and rovers. Next slide, please. But in the red here is all the missions that are no longer alive, including landers and rovers as well. So, you know, rest in peace, landers and rovers and orbiters. But there's still quite a bit still going strong on the red planet. There's still all sorts of exciting missions to be coming about, especially with Mars sample returns. So that's somewhat of Perseverance Part 2. So as Perseverance is roving around the planet, it is going to start collecting certain samples to be tagged for an eventual sample return. So that's going to be really exciting. Next slide, please. Yeah, so in the very beginning of getting images of Mars, this was essentially what we had to work with. So extremely low res. Now, if you squint your eyes and tilt your head, you might be able to see some sort of geology there, but good luck. Next slide, please. So thankfully, we have way higher resolution images for Mars. The highest resolution images we have is from the Mars high-rise camera. Next slide, please. And with that particular camera and then all sorts of other kind of spectroscopy type instruments on other orbiters, and certainly with landers and rovers, now we can really figure out not just the different kinds of geology on the surface of Mars, but also what is everything even made out of? What kind of minerals and rocks are we dealing with? And then how do we even know what we're looking at? Next slide, please. So fundamentally, Mars being a terrestrial planet, it's essentially an igneous planet. So we're dealing with like I said earlier, lots of volcanoes and some magma there. Next slide, please. So all sorts of mineral data from Themis tests. There's also mini tests on the rovers, Chrism, Omega as well. So I won't get into all the fun acronyms there, but all the different kinds of mineralogical spectrometers on orbiters and rovers. Next slide, please. But something really interesting to think about too is we test a lot of these instruments here on Earth, especially say like the volcanoes of Hawaii and Iceland. Very, very similar to what we think might be going on Mars. So we test some instruments there. A lot of the mineralogy is essentially the same. We could also figure out some of the mineralogy from Martian meteorites as well. So that's also exciting. And I'll share some exciting stuff about Martian meteorites here in a bit. Next slide, please. Okay, here we go. So here's our lovely Mars Reconnaissance Orbiter high-rise camera. So this is 19.7-inch aperture. It could get down to at least 15 centimeters per pixel resolution. It is a fantastic, very large camera, and has picked up some really, really interesting features. And so most of the images I'll be showing near the end of the presentation is from the high-rise camera. And the great part is that all these images are freely available to the public. So I highly encourage you to Google Mars high-rise, and should be the first link on Google, and you can just go through their gallery. There are also images that if you have any 3D glasses at home, you could also have some fun on your laptop screen and have some fun with some Mars images, anaglyphs as there. Next slide, please. So So another fantastic rover that has really helped us out with mineralogy is the Curiosity rover that landed in Gale Crater. Next slide, please. And then certainly the Perseverance rover, which is very, very large rover, and many different kinds of mineralogical sensors on there as well. Next slide, please. So getting all the sorts of fun panoramic views on Mars, now we can figure out textures of rocks up close. We can see how maybe how well sorted a lot of the boulders versus even down the pebble-sized rocks can be. Next slide, please. And then these are what some mineralogical images would look like. So similar to the geologic map that I just showed, every single color that you see here is a different kind of mineral. It's very, very rainbows with most of these images. It's really, really pretty. But that could tell us a lot about anything from craters and impacting to if there's ice involved. There could be different kinds of colors there as well. A lot of olivine in this particular picture. So very fun colors. Next slide, please. So it may look like shiny rainbow images and everything though, but it takes many hours to even make such an image though. And so this is just a taste as to what all goes into making those kinds of images that we look at spectra that you see on the right there. So spectra in that case is that, think of it as every mineral having its own fingerprint. And so a spectral camera or a spectrometer would pick up those different kinds of fingerprints. And then we would have to figure out, okay, how does that fingerprint match, say, olivine or different kinds of iron, magnesium type minerals? Maybe it matches over to labradorite or talc or kaolinite, any of those kinds of minerals. Next slide, please. So in that case, Mars has a lot of very common minerals that we even have here on Earth. So it's very, very, I don't want to say easy, but certainly exciting, if anything, to find all these different kinds of minerals on Mars as well. So the usual suspects would certainly be hematite. But it's exciting to find gypsum and dolomite and bits of montmorillonite and certainly quartz and different kinds of quartz as well. All right, next slide, please. So onward to real quick about Martian meteorites. So we call these SNCs. Just go forward 3 times. Thank you. So we have our sugatites. So these are mostly basaltic type meteorites, nacklites. So you got your augite and olivine, and then shagagnites. So mostly olivine in that case though. So SNCs are quite uncommon, but how we even know that they are Martian meteorites, not just a piece of gravel that you would find in, say, Rhode Island, is that meteorites, again, hold a certain fingerprint. Every planet would have a certain fingerprint across the solar system. So Mars holds a very specific type of oxygen isotope that is very, very specific to ours. And this is how we find out why, or how a meteorite is from the asteroid belt versus the moon, or like I said, a piece of gravel from Rhode Island. Next slide, please. So this is probably one of the most beautiful Martian meteorites that we have collected out of Morocco, and it's called Black Beauty. The more official name is NWA 7034, but that's not a very fun name to say. So Black Beauty it is. It's a fantastically beautiful dark black sheen to it. So this picture, we took like a small slice of it so you can see a bit of inside to it as well. It's mostly has some pyroxenes in it. Next slide, please. So this is exciting too. So from other Martian meteorites that we have collected, as of 2014, we have actually found 2 new minerals, tisentite and Ahrensite. So these were only found, I believe, in higher pressure conditions. And so that that right there really can tell us a lot about what conditions on Mars and how it would have formed within the meteorite, how these minerals would have formed. And when I mean new minerals, I mean these are not found on Earth. So very exciting. Next slide, please. All right. So rocks from rovers. Next slide, please. So this is kind of a nice little slideshow as to all the different kinds of rocks. They're very, very fun names as well. I don't know most of the why some of these are named. Some of them will be very obvious here in a bit, but some of them are just, I think rover teams had a little too much fun with some of the naming of some of these rocks. But pay close attention to like the texture of some of these boulders, though, especially Barnacle Bill here. It looks a very fluffy, porous rock there. Next slide, please. El Capitan, you would have a lot more striations there, so definitely a layered stratigraphy there in the rock bed there. Next slide. He Shield Rock, gee, not a hard name to follow on that one though. This one was taken by the Opportunity rover. Very, very nice iron piece there. Next slide. The Hota Rock outcrop, so possibly some stream bed action going on here taken by the Curiosity rover. Next slide, please. This one I really enjoy because then you can see all the different kinds of pebbles going on here. So different kinds of sedimentary conglomerates, similar to different kinds of fluvial streams here on Earth. So this is taken by the Curiosity rover. Next slide, please. And I love this. There's hardly any large rocks around, and then just the lone rock in the middle of the field here. That one of the rovers took, and they're like, oh, hey, I want to go investigate. So next slide, please. There it is. So this is from the Opportunity rover. This is considered a false color image, so it is not this pretty orange and purple type rock, but the false color can really help us figure out the iron and nickel part of rocks here. Next slide, please. I like this one too, pot of gold. So this was a very knobby textured outcrop. So most of the knobby textures that you see here are typical of hematite. Next slide, please. So speaking of hematite, there are also blueberries on Mars. So this was a very fun image. Again, this is slightly false color images just to bring out the bluish hue of hematite. But if anybody is familiar with Moki balls, usually in the southwest of the US, these are very, very fun to find on Mars as well. But we call them blueberries because they show up blue with our false color images. Next slide, please. All right, now we can get into the really fun macro scale geology here. So next slide, please. Let's just dig right into it. So our crowning jewel of Mars is Olympus Mons. So Olympus Mons is not only the largest volcano on Mars, it's also the largest volcano in the entire solar system. So the base of Olympus Mons can pretty much swallow the state of Arizona. So very, very large, but not terribly steep slope unless you're looking at, in this case, the bottom right corner of this image. It's a complete cliff face there. So how it just kind of shuffled off of there is still actually being investigated. But notice though in the middle part of it though is that it's not a clean singular vent there on the volcano. Next slide, please. So this is what it looks like up top. So in the center though, probably noticed though that it's, again, not totally circular, but that there's multiple indents there. So what happens here is that it's called a nested caldera. So if for those of you who don't know what a caldera is, it's when a volcano erupts and then it pretty much scabs over. And by scabbing over though, it puts too much pressure on top. And there's nothing to hold it up anymore, and it essentially just collapses down into a pit until it fills back up again with activity, and then it explodes with lava again, and then it fills up and then collapses, and it can continue to do this over and over and over again. And so I believe the current count for how many different kinds of holes the top of Olympus Mons is about 8. And so this would have, so 8 different times of eruption with Olympus Mons. Next slide, please. So Olympus Mons shares a similar volcanic region with many different other kinds of sister volcanoes there. This region is called the Tharsis Bulge. So you have a beautiful alignment of 3 much smaller volcanoes there, but notice though that the vents on these volcanoes are a little bit more circular and not as multiply indented as Olympus Mons. Next slide, please. Yeah, so here's an elevation map. So the white and red areas of this image are your much higher elevations. Your blues and purples are your lower elevations. So this entire red blotch that you see here, this is our Tharsis Bulge. And so why we see alignments of some of these volcanic systems, or why Olympus Mons doesn't seem to be in the center of this large bulge as well. This is still somewhat ongoing investigations. What's interesting though that we have to keep in mind is that Mars does not have tectonic plates. So it'd make things a lot easier if it did. It'd certainly make our jobs a lot easier if it did, maybe. But because Mars, and who knows, maybe it did at one point, but probably not. How these would have been aligned, we're probably thinking something similar to the how Hawaiian island volcanic chains are formed. You would have hot spots move in some sort of alignment. But the bulge itself and how it came to be and the evolution of these volcanic systems, why only those 3 in alignment and not any more than that. All of these are very much ongoing questions that are still so fascinating. Next slide, please. All right, so stemming from volcanism, now we could also have what's called mud volcanism. These are found in Arcadia Planitia, so northern latitudes of Mars. These are really tiny. These can grow maybe about up to 3 kilometers, so quite tiny. I know I realize 3 kilometers might be a bit large, but in the case of much larger geology on Mars, these are quite small and can end up in small clusters like this. Now, when I mean mud, I don't mean soil here on Earth or anything though, but mud in the sense of having some sort of gravelly, slushy, typically mostly magnesium and ice mixtures. Just kind of makes everything very sloshy. Next slide, please. So interesting textures from lava plains on Mars, and in that case I can certainly show dozens of different kinds of lava textures on Mars, but this is probably one of my favorite ones. So this is something that all the images I'm going to show you are still very much ongoing investigations and some really fun and weird mysteries as to how certain geologies are on Mars. So as far as textures go, why do we see different kinds of textures all over Mars? Different kinds of volcanic systems. Some have more pockets of ice that can really influence your texture. Some don't. The more magnesium or even salts that you have would influence your texture. So just looking at the different kinds of lava texture here is very, very pretty. Next slide, please. This is really, really pretty. There's a whole opal field right near Valles Marineris. It's absolutely gorgeous. So this is a false color image of the opal field. Now, when I mean opals, though, I don't mean probably not gem quality, unfortunately. So gosh darn. But we do realize that it is opal by the spectral images and cameras on orbiters. Next slide, please. So this is what I'm meaning by salt. So there are salt flats, there are salt fields, and a lot of gypsum, especially around Candor Chasma. So all of those kinds of salt pits and hills, very similar that we would see even here in the US, or even salt domes that we would see in the Middle East as well. Very, very similar morphology that we would have here on Mars. Next slide, please. Just some more images of salt fields, also at Candor Chasma there. Next slide, please. Chloride salts. So I notice how chunky this texture is compared to the more wavy, smoother salt fields that we just saw at Candor. So understanding salts, how did salts even come to be? Because if you have salt, that means that you would have had some sort of liquid water at some point. And so how salts are, what's their origin, what's their evolution on Mars is a very, very fascinating topic. Quite a bit of experimental laboratory work is being done around the nation, actually, to understand salts at Martian conditions, which is very, very cool. Next slide, please. So this is a slight mineral map of Jezero craters. So this is where the Perseverance rover landed near. So again, every color that you see here would be a different kind of mineralogy and somewhat different kinds of geology there. So you can see this beautiful delta fan that has spilled out into the Jezero crater there. It's just absolutely gorgeous. So it's really exciting to figure out what all kinds of rock samples the Perseverance rover is currently studying, and hopefully to be collected and brought back to Earth at some point. Next slide, please. Oh, okay. Yep. So there we go. That's where Perseverance landed. Anyways, so onward then to other bits of geology on Mars. So this, we love looking at craters. Yes, they are beautiful, fancy holes in the ground. Okay. But craters can really tell us a lot about the subsurface. So for this particular crater, as tiny as it is, whatever excavated was some sort of very, very dark material for it to splatter outward. Next slide, please. Craters could also tell us a lot on different kinds of morphologies within the crater as well. So in this particular crater, there's dunes at the very bottom, but then all around the edges are gullies, and you can have different kinds of troughs cutting into the rock walls there of the craters. You know, some of these even show seasonal variations as well. And I'll give an example of a seasonal variation here in a bit. Next slide, please. Another fun thing about craters too is that some of them have what they end up looking like flowers, just very large, what we call lobate deposits. So all of these, you would have some sort of impactor make a hole, and then whatever is excavated doesn't really puff upwards, but instead liquefies and then spreads out into these lobes, what look like flower petals, out in different directions. And so how big the lobes are, how squishy or how textured some of these lobes can be, can really tell us about what actually got liquefied. You know, is there a lot of ice, in which case you would get a lot of lobes and knobby type of textures. If they're smoother, that usually means you have a lot of quartz, a lot of silica type minerals. Next slide, please. I love tectonics. I love geophysics. So this is a very highly fractured area on Mars. So it just looks like just pure chaos of fault lines just completely thrashing it, cross-cutting against each other there. Next slide, please. So these are very, very fun images to look at. All the crazy little dark lines here that just kind of squiggle every which way. Looks like something out of Tim Burton, honestly. So all these dark squiggly lines that you see here are actually dust devil tracks. Next slide, please. So dust devils are very, very interesting for rovers to encounter. They're interesting to also encounter via orbiters, but much harder to actually catch one in action. So this is from one of the rovers that happened to be near some bits of dust devils. Again, you can Google dust devils on Mars and get many more videos and GIFs just like this one. Next slide, please. So yep, just more dust devil tracks there, but you might notice some very weird lines kind of creeping in from the bottom left there. And so these would actually be considered bits of gully systems. So again, gullies, if I say the word gully, a lot of people would automatically think like, oh, it's wet, there's water, it's moist, something. And you'd be mostly correct. There would be some sort of water and salt involved with a lot of these, but why they're found in certain areas on Mars, or are they seasonal, or are they perpetually growing? Are they shrinking? That's still being investigated. Next slide, please. Dunes, lots of dunes. There's, Mars is an incredibly dusty planet, so it makes sense that there's going to be lots of dune fields on Mars. And so there are many different kinds of dunes, many different shapes and sizes of these dunes that can span for miles and miles and miles across the surface. Next slide, please. Okay, so this may take a while for your eyes to get trained to see what in the world is going on. So all of the squiggles that you see here are actually supposed to be going into the screen. So all the flat areas, the flat, smoother areas are actually supposed to be higher elevation popping out of the screen. So I do realize that it probably looks the complete opposite. It really does take a while and a trained eye to look at these kinds of features. But this is just a small area of something that happens throughout most of the South Pole of Mars. So the South Pole of Mars doesn't have a lot of water ice. It has actually mostly carbon dioxide ice. And what happens with carbon dioxide ice is that it sublimates and creates these beautifully wonderful, very bizarre pits. But in that case, we don't really quite know what else is going on here. It couldn't just be carbon dioxide. So something else is going on here, probably some sort of mixture of dust within the carbon dioxide as well to make all the really cool, weird patterns here. But essentially, we don't really have an official name for this except that we just call it Swiss cheese. So yes, so there is Swiss cheese on Mars. So lo and behold, we found Swiss cheese on Mars, but yet no cheese on the moon just yet. All right, next slide, please. So I love this one though. You can legitimately Google happy face on Mars, and then there's a Swiss cheese pit that looks like this. So anybody go to Eaton Park, it looks like an Eaton Park cookie. All right, next slide, please. Okay, so these are probably the, in my opinion, some of the coolest features on Mars. So these are seasonal. These are called spiders. So not to creep out on anybody, and I hope and no one is arachnophobic like I am. But yes, there are spiders on Mars. Now, the more official term for these are called arachniforms. But these only pop out in the springtime. So what's happening here is that you have carbon dioxide and nitrogen frosts and vapors that just kind of hang out in the winter. They freeze usually onto dunes and onto the sand and low-lying plains on Mars, and that frost just kind of gets buried into your winter frost there. So as spring arises, all that frost is going to sublimate. You don't really get much in the way of melting on Mars. You either just freeze or you immediately thaw and sublimate. So as it's sublimating, all that nitrogen and carbon dioxide that just got trapped into that ice wants to be released. And when it releases, it creates kind of a quick, very dark black powder, itty bitty little vapors. And when these go poof, it creates little itty bitty geysers like these. And they don't last very long. They last a couple weeks, maybe even up to a month. And then they'll go away, they'll dissipate, and then we wait for winter to come back around and it'll start the process all over again. So we know it's spider season whenever it becomes spring on Mars. So very exciting and slightly terrifying. Next slide, please. And so for the final geology I'll mention here is not just beautiful mountain landscapes that we would have on Mars, but almost to the sides of some of these mountain ranges as well. So if we were to zoom into the top part of this image, next slide, please. We get what's called RSLs. That's the acronym. So the acronym stands for recurring slope lineae. So recurring slope lineae means you have these very smooth looking sandy, dusty slopes with very dark streaks running down them. And these streaks will disappear and reappear and disappear and reappear. Sometimes different lengths, sometimes even the same length, but they usually show up typically in their same places. But are they seasonal? Are they? There's a whole debate going around on the Mars community as to is Mars wet versus dry? Are these currently liquid, or are they simply dark dust streaks that appear, whether it's similar to the spiders and then they just kind of sublimate and then disappear and sublimate and reappear and so on, or is it really liquid water that's just kind of trickling down for just a little bit, then it just kind of stops and then disappears and just kind of reoccurs seasonally. So all of this is still very much under debate. I think the current favored theory is that these are considered dry, but I'll leave it up to everybody on the Zoom call here as to what do you guys think? So next slide, please. So some shameless promotion here. So I got to write a few chapters with the latest Mars volcanic textbook that is currently available for everybody through Springer. It's called Mars, A Volcanic World. So if you want to learn more about the ins and outs of the volcanic systems on Mars, or lava textures, or even Martian meteorites, and what can meteorites tell us about the volcanoes on Mars, feel free to take a look at the book. Next slide, please. I believe, Yep, so that is my last slide. So thank you all so much for having me back this evening. I apologize again for the technical difficulties, but thank you all so much for hanging in there, and happy to answer any questions you may have. So thank you so much.
Thanks, Caitlin. That was a great presentation and it worked out fine with the technical difficulties, so no worries there. There was one question already in the chat. Can we make the slide available to viewers? The slides available to viewers?
Sure, absolutely. So well, okay, so you already have a copy. Chris, I could send you a copy and then you can send it around.
Can we add it to the website with this video?
Yeah, absolutely.
Okay.
That'll work. That'll be easier. Yeah.
Yeah. All right. I'll start off with a question, but everybody else, yeah, if you have any questions, feel free to add them to the chat, or yeah, you can unmute yourself and ask your question out loud. My question is regarding the mineral rainbow images. How does that compare to the to similar images to the deserts on Earth? Is it very similar? If it's not that similar, what different processes are in play that would make that different?
That's a fantastic question. So it's very similar. So to make those kinds of maps, you essentially have to teach your instrument and teach eventually your like computer coding program and everything to read your instrument and your data. We have to teach the program, okay, what minerals are we even supposed to look at? So all the minerals are from Earth. So there's mineral libraries, mostly through Arizona State University and Northern Arizona University, that keep mineral databases of all the different kind of squiggly lines that I showed a couple slides back, the spectra there. So all that spectra gets fed in and then compared with data of whatever we get back from, whether it's rovers, orbiters, and whatnot. And then we try to match. If you get one squiggly line and it matches up with quartz, then there's our match. Now it's not going to be exact matches, but some minerals are way easier to spot. Quartz is definitely an easy one, for sure. But some clay minerals much harder to figure out, because clays can come in all sorts of different kinds of grain sizes, different kind of mixtures as well. Can you really get pure clays on another planet? Probably not. So there's always some sort of weird technical aspects with it, though. But yeah, so keeping all these kind of mineral libraries that we get here on Earth from the different kinds of dune fields and different kinds of minerals all over the world really help us figure out, okay, what in the world are we even looking at on Mars?
Great, thank you, Caitlin. Got a lot of kudos from Deb, Paul, Jason, Alton, Jessica, Stephen, Stephanie, Nicholas, George, Jill. I don't know if I can name everybody here. Lots of praise for this presentation. It's great. They love the pictures. We did have a question in here. Let me see if I can find it again. From Saul Ash. Mars has no magnetic field or tectonic plates. Therefore, it has no core, mantle, and crust. That's a question.
So that's the fun part. It does have a core and mantle. They're just no longer alive. So we do know that there is a core and mantle, mostly because there are volcanic systems. You would definitely need some sort of active mantle with that. We do, I guess, predict, assume, hypothesize, that's the word, that Mars would have had a magnetic field. So there are remnants of a magnetic field around. If you were to Google a magnetic field of Mars, it looks like a very sad, tangled ball of yarn. It doesn't look pretty like Earth or even Jupiter's magnetic fields anymore. So what happened? What happened to that magnetic field? Why isn't the core no longer active? Why is the mantle no longer producing volcanoes and lava anymore? So all of that is beautifully mysterious and or a bit of a headache to those who are actually studying planetary interiors. Mainly because, yeah, exactly what happened to make such a planetary core of all things just completely slow down, that it can no longer generate a magnetic field. So a big guess in it is that Mars would have been whacked very hard early in its life and slowed stuff down. So that's I think a current favored hypothesis, but I think there's several other hypotheses out there.
This is Saul. Thank you for your answer. Taking that one step further, if there are no tectonic plates, then there's no large scale mountain building, but yet we saw pictures of mountains. So is that simply due to fault block mountains, or as a function of geologic time, there hasn't been enough time for more differentiation into a continental crust? I don't know if I'm being clear on that.
You are. So you are correct. A lot of that would be definitely fault building and just kind of, let's see, what would be the fun word here? Scrunching, scrunching blocks upward. And then erosion takes place to shave off the sides and make most of those mountains. So yeah, that is perfectly accurate there. Of just a lot of this would be faulting in a sense. So not plates colliding and having or yeah, mountain building type processes that we would have here. But definitely faults. I had showed a slide about all the different kinds of cross-cutting faults there. We also know that there is some Mars quakes going on Mars, thanks to the Mars InSight lander. Now, Mars quakes probably aren't spectacularly big. I think the biggest one to date is like a 4.7 magnitude. So some shaking there, but not Mars shattering.
I got your pun there. Very cute.
Thank you.
We had a question from Mike Wolfert. I think it was a two-parter. Are there any metamorphic rocks on Mars? And then he asked a question about Mars's age.
Oh, fantastic question on that. Let's see. So metamorphic rocks. I'm trying to remember my rock cycles here. Let's see. Yeah, because most of these would certainly be igneous, and whether they would be volcanic and versus intrusive. Metamorphic rocks, though. Possibly. I don't think we've had any zircons from Mars, although that would be awesome if we did, but not to my knowledge. Now, have we found hydrothermal type rocks? Absolutely. But metamorphic, not entirely sure on that. Yeah. Okay. So as far as Mars age goes, it's about 4.6 billion years old. So pretty old.
Rich Baldwin, thank you for joining us again. Did we speak of volcanic ice interactions?
Yes. So interestingly enough, before Jezero Crater got selected as the final Perseverance rover landing site, beforehand, there were at least 3 different landing sites, and one of them was called Northeast Syrtis. And Northeast Syrtis would have been a beautiful ice volcanic interaction area there for the Perseverance rover. But everybody loves astrobiology, and everybody wants to look at, follow the water. so the obvious choice there was Jezero. But not to say that Northeast Syrtis is going to have its time in a spotlight, hopefully with a future lander or rover there. And so ice and volcanic interactions are fascinating, because then your geology, you're dealing with literal hot and cold.
Yeah, I was a planetary geologist with the USGS decades ago, and we were looking at Yakulips and the channel scablands and things like that.
Oh yeah, oh absolutely, that's gorgeous.
Are there any other questions? Great. I think I'm going to hand it back over to Chris.
All right. Well, thank you, Jennifer. Caitlin, you hit it out of the park again. I have to say thank you so much. That was a great presentation, some really crazy stuff. I had a question for you. With the spectroscopy surveys of planet-wide, and I know you're picking up minerals and clays and things like that, has anybody started to do research or figure out just how much of when Mars was wet, how much of Mars may have been covered with water at at its maximum, based on the mineralogy that you see? That's all has to have some water history in its formation.
Oh, absolutely. And it's one of those questions where it's so large that it's truly taking most, if not all, of the Mars community just to dive into that. And so I personally think we've just barely started on that particular quest. But yes, by all means, that's on the top of our to-do list to investigate, because it's going to take a while for sure. There's many different areas to look at, all the different kinds of geology, back to salt as well. So salt can really do some weird chemistry with liquids, and you lower your freezing point down. So what does that mean for ice? How did the salt even get there in the first place? What kinds of salt? There's different kinds of salt. Ta-da! It's not just table salt. On Mars, you could also have magnesium chlorides. You can, I believe, you could also have lithium chlorides as well. So all of the different kinds of chemistry, the mineralogy, and then the bigger scale geology, all of those separately are being investigated. But then trying to bring that all back together and bigger picture, what does this all mean to investigate water on Mars? That's going to take a while. But then that's why we need people to specifically look at only the salts and only gypsum, or only this part of Mars versus this other part of Mars. So only looking at those smaller puzzle pieces. And then we have people that do look at overall, where would the water have been? Where did it all go? How cold and dry versus cold and wet was Mars in its early past? So all of this is still very much fascinating. So who knows where it's going to go?
Good answer.
Thank you.
I mean, the topography doesn't like suggest ocean basins like we have here on Earth, but with the absence of real long-term tectonism, you wouldn't really expect that, you know? You're not gonna have trenches and things like that.
There's also vast areas of the uplands that have crater counts of like 4.6 billion years old, which is kind of sort of argued against a planet-wide atmosphere for some practitioners.
Yes.
I'm just gonna make one more comment, and that was, I thought it was really interesting when you showed some fairly large iron nickel meteorites laying in a field that didn't really seem like you would think an object of the size that we were looking at, if the scale was right in my perception, would have made a pretty darn big hole in the ground.
Exactly.
And you don't see that.
Right, exactly. And so there's all sorts of fun stuff going on here. So whether they were there might have been like gentle slopes nearby and it just kind of tumbled in, or there's a much larger rock underneath and we're only seeing tip of iceberg layer there. More than likely not that one. Or were there other rocks around and everything else got eroded away, and that was like the one iron deposit? Maybe there was an impact and then the rest of the impact was shallow and then eroded. So there's all sorts of different kinds of scenarios you can have here. But no, I fully agree. It's so bizarre to just see a lone rock in the middle of literal nowhere on Mars and just go, oh, shiny rock.
We forgot the most obvious scenario. Marvin could have moved it because it was in his way, and that's where he placed it.
Where's the kaboom?
Well, Marvin just placed it down gently. He's a gentle Martian.
The Earth.
Where's the earth-shattering kaboom?
Chris, do we need to share the 3 questions on the screen, or do you just ask them? The PDH questions?
Yeah, I'm just gonna ask them and not sure if everybody will get them or not, but we have 3 questions. You can just put your answer in the chat. No judgment here. First question, which planet is the largest? Mars, Earth, or Venus? People are still answering. You go for it. By the way, you're all wrong. Earth is spelled U-R-T-H. Thank you, John.
Thank you, John.
It's more like it. All right, next question. Who had the first mission to Mars? The United States, China, Soviet Union, or Russia? Well, it looks like most people are saying the United States. but we have some controversy here. Well, Caitlin, back me up here. It's the United States, right?
I
Do you
so.
know? You remember?
I think so.
And
I think
the-
first, at least first successful mission.
that's right. That's right. Russia's definitely the Soviet Union and Russia definitely sent things that disappeared.
Yeah, which happened more often than not back in the 60s. Yes. Okay. Yep. Mariner 4 says USA.
But it's still tough to get to Mars successfully.
Oh, yes, very much.
All right. And Earth is the largest planet. So last question. Which of the following were observed by Spirit and Opportunity? Those are the rovers, for those of you who weren't paying attention. Ancient magma, dune activity, frost, or all the above. Who said Russians?
I just saw that whiz by in the chat.
I was gonna make a joke that, you know, all the Russian things that disappeared was because they had some unwanted oligarchs on them.
Oh my goodness, that made my night.
All right. I think that's probably enough about that, but I think the answer is all the above. Or no?
Yes. Yeah,
It is. Okay.
it is.
Yeah. Derek, thanks, Derek, for not giving me the answers.
Whenever you're taking a multiple choice quiz, if there's all of the above, just check it. You know, that's probably right.
All right. I think that's it on the questions. Any other questions or comments? Anybody want to volunteer for the next presentation? All right. Well, listen, we're at time now. It's 8:30, and I want to say thank you again to Dr. Ahrens. Really hit a home run every time. We so much appreciate you coming out and doing this for us. We had, I think, close to 60 people tonight, and that's awesome. Awesome. You
Thank you.
You expanded our minds, that's for sure.
Thank you so much again for having me back. Everyone still listening out there, definitely go check out Mars High Rise images. They're a fantastic image gallery there. For those of you who didn't hear me earlier, though, if you have a cheap pair of 3D glasses at home, they're starting to add more anaglyph, that blue-red filter on some of those images, so you can have some fun with some 3D Mars images in the comfort of your home, or even in your classroom as well. Thank you so much again for having me this evening.
So cool. All right. Everyone that applied for the PDH credit, we'll get those certs out to you. Thank you so much again for everything. And with that, I think we'll wrap it up. So good night to all. Be well, be safe. Stare at Mars when it's out in the sky.
Right. Thank you.